So today we are going to take the lecture number 3, in which we are going to cover the co-tree, link and the basic concepts of the basic loops, basic cut set and the incident matrix, right. So in the previous lecture we have studied about the tree, and for which some topic has been left. So this is the course content of your first unit. This much we have already covered in the lecture number 2. So some part of the tree is been continued here. So these are the few properties of tree. So a tree, as already mentioned in the previous lecture also, what is the definition of tree, and we have also seen the trees, how to form it. So it always consists of all the nodes in the electrical network, and it is not having any closed path in it, right. And the tree of a graph is not going to be unique, it can be different also. So it is possible to make many different number of trees from a same electrical network. This is the fourth property, and if the graph contains n number of nodes, then the tree will have n minus 1 number of branches in it, right. So we have already seen in the previous lecture also. So the branches of the tree is n minus 1, and these branches of the tree are called the twigs, right. So the number of KCL equation is n minus 1, which is equal to the number of twigs. So these are the basic properties of tree. Now we will go with the next concept of co-tree. So it is a subgraph basically, which is formed after disconnecting a tree from a graph, right. So we will take the same example we have taken previously. For this we will just bifurcate in tree and co-tree both. Tree and co-tree. In the last lecture we have made 3 trees with it, so we will take the same 3 trees. This is 1 node, 2 node, 3 node, 4 node. This is the tree which is covering all the nodes, but it is not containing any closed loop, right. So this is the tree branches which is having the twigs number 2, 4 and this is 5 branch number. If we denote the orientation also, this is the direction which is saying the orientation. So we will denote it by the arrow sign, right. So this is a tree made, right. So from this a co-tree is made, then it is basically the branches. This branches has been taken for the tree, this branches is taken in the tree, this branch is taken in the tree. So the branches which has been left, which is not considered in this tree, is called the co-tree. So what are the other branches which has been left? 2, 4 and 5 are taken in the tree. So it means ki branch number 1, 3 and 6 is left. So these are the branches of the co-tree. So this is the third number branch which is connecting first and the third node. This is the second branch which is the first number which is connecting first node and the fourth node, and this is the fourth node, which is this is the fourth branch, this is the third branch which is connecting the node 4 and 3, having a branch number 6. So 1, 3 and 6 are the branches of the co-tree, right. Similarly if we take the another branch, so there is a way to make a tree and a co-tree on the same graph, which can be shown here. Suppose we are taking this tree 1, 2, 3, 4. All the nodes are connected and there is no formation of any closed loop, right. So this is a tree which is containing branch 2, 5 and 3, right. So the branches left will be shown by your dotted lines, or we can say this breaked lines, right. So it is showing the branch of your co-tree which has been left, is not considered in the tree, is shown by a dashed line which is called the co-tree, right. So this is the branch number 4, this is the branch number 4, this is branch number 6, this is branch number first, right. So, first, fourth, and the 6 branches are in co-tree, and the branches in the tree is 2, 3 and 5, right. So, this is the next co-tree. So, if we see the property of it, it says that the branches of the co-tree is called the chords. It means that the branches which we have written here, first, fourth and the sixth, which is the branch of your co-tree, it is called the chords, right. It is called the chords. And now, we have already seen the branch numbers. The tree branch is nothing but it is equal to n minus 1, right. So, suppose for example, if you take this tree and co-tree sets, there are 1, 2, 3, means 2, 3, 5 is the tree branches, it is called the twigs. So, it is basically in this figure there are n is equal to 4 and b number of branches is equal to 6, right. So, n minus 1 is 4 minus 1, that is equal to 3. So, we can see here there are 3 number of branches in your tree, and what is left will be the co-tree branches, right. So, what is left, total number of branches is b. So, b, what is left will be b minus n minus 1, right, n minus 1. N minus 1, n minus 1, right. So, for this figure b is 6 minus 4 minus 1. So, it is equal to 6 minus 3, that is equal to 3. So, there are already 3 number of branches in your co-tree, that is called the chords. So, from here this property is also clear that the number of branches in your co-tree is b minus n minus 1, that is called the chords. And since the sum of the number of branches in the tree and the co-tree is called the total number of branches, here it is written the sum of the number of branches in the tree and the number of branches in its co-tree is equal to the total number of branches, right. It means ki n minus 1 is the branches of tree plus b minus n minus 1 is the total number of branches in the whole graph. So, it is always equal to b, right. So, this is the properties of the co-tree. Now, the next concept is the basic or the fundamental loops. It is actually a loop which is a closed path, right, of a given graph which contains this one. Only one and only one chord will be available in that loop, and the remaining branches is the tree branch, right. It means that there is a loop which is containing only one and one chord branch, one and one co-tree branch, that is the chord, and the remaining branches in that loop will be the tree branches, right. So, the number of fundamental loops for a given graph is equal to b minus n minus 1. Number of fundamental loops in a graph, given graph will be b minus n minus 1, that is equal to the number of chords also, and it is equal to the number of KVL equation that can be formed from a given graph, right. So, these fundamental loops are also called as fundamental tie sets, right. So, fundamental is written by F and this tie set is written in short form like this. In many books you can see that it is F tie set, that is the fundamental tie sets, right. Now, the next property of the fundamental loop is the direction of the F tie set, that is the fundamental tie sets, is same as the direction of your chord. So, here the orientations came into picture, that is the direction of your loop, fundamental loop, that is the fundamental tie set, is same as the direction of your chord. Fundamental loop will consider only one and one chord, and the remaining will be the tree branches, right. So, the direction of the fundamental tie set is same as the direction of your chord. So, we will see with the same example of the graph. Here the same graph has been taken, the orientation has been shown by the arrow which is going to be play a role here. Suppose for example, it says that fundamental loop containing only one chord, right. It means ki it is containing only one co-tree branch. Suppose we are taking this tree, it is having 1, 2, 3 and 4 nodes. This is the second branch, this is the fourth one and this is the fifth, right. So, this one tree has been taken. Now for fundamental loops, it says that the loop will contain only one and one chords, right? It will have only one chord tree branch. So if we draw the chord tree also, it means the branches which are left means it is not in your tree is the chord tree, right? So these are the shown by the dashed lines, which is actually the chord tree branch, right? So this is branch number 3, this is branch number 6, this is branch number 1, right? So there are in this graph we have taken only one tree, right? So as the previous slide says, there are number of fundamental loops will be b minus n minus 1, which is equal to basically 6 minus 4 minus 1, that is equal to 3. It means for that given tree, for considering this tree, we will have three number of fundamental loops. See, fundamental loop says that it contains only one and one chords, right? It means ki if we take this loop, it is containing 2 branch, 5 branch and 1 branch, right? It can be seen that this one branch is the only branch which is the chord tree branch. It means it is a one chord. And the next property also says that the direction of the fundamental loop is same as the direction of your chords, right? It means ki this loop's direction will be same as the direction of your chord, right? It means ki the fundamental loop's direction will be in the same direction of your chord direction, right? So the fundamental tie set is L1, that is the loop number 1. This is the loop number 1. It is basically the branches which is 1, 2 and 5, right? 1 is the chord tree branch, that is the chord, and this 2 and 5 are the twigs, right? Similarly, if we take this loop, loop means closed path, it is containing 2, 4 and 3, that is loop 2. We can say this loop 2 is containing the branches 2, 3 and 4, right? And the direction of this fundamental loop or F tie set is the same as the direction of your chord, right? It is the dashed line which having the direction this. So this fundamental loop's direction is also like this. So this 2 and the 4 is the twig, this 2 and 4 is the twig, and this third is the chord, right? So this is the loop number 1, this is loop number 3. And according to the previous slide, it says that for this there are 3 number of fundamental loops. These 2 loops has been completed. See, there is one loop left, which is this one. This loop is containing branch 4, 5 and 6. This is loop number 2, this is loop number 3. This is loop number 3. So loop number 3 is containing the branches 4, 5 and 6, right? In this 6th branch, this 6th number branch is the chord, the 6th number branch is the chord, and the 4 and the 5 branches, this 4 number branches and the 5 number branches is shown by the solid lines. This is actually the tree branches, which is the twigs, right? So this is how we go for the fundamental tie sets, right? So this concept is going to be used further, that is why we are studying here. Now the next concept is the basic or fundamental cut set. The previous one was basic or fundamental loops, now it is the cut sets. Basically fundamental cut set is written as F cut set, that is F stands for fundamental, right? It is a cut through a graph. Basically this fundamental cut sets actually cuts the branches into 2 parts, right? It cuts the whole graph in 2 parts, and any F cut sets contains one and only one tree branches, right? In the previous one, it was containing one and only one chords, right? But here it will contain only one tree branches, that is the twigs, and the remaining are the chords, right? So just opposite of the fundamental loops. It is previous one was containing the chords, only one chords, and here it is containing only one tree. Now the direction of each cut set is same as the direction of your tree, which is containing only one, that will be the direction of your fundamental cut sets, right. It is same as the direction of your tree branches. Now, for the previous one, it was containing number of fundamental loops was b minus n minus 1. Now, here the number of fundamental cut set is nothing but the n minus 1, which is equal to the number of twigs and which is also equal to the number of KCL equations, right. So, we will see with the same example. Here the same graph has been taken. I just take one tree, similar tree, branch denoting the branches and the nodes 1, 2, 3, 4, these are the nodes. Branches will be shown by the numbers in a bracket. This is branch number 4, this is branch number 5, right. And I will show the code tree by the dashed lines. With the orientation of the branches also 1, and this is branch number 6. So, your fundamental cut set says that it is a cut which is going to divide your graph in two parts, right, and it will contain, that cut will contain one and only one tree, right. So, see here I am just going to cut these branches, cut the graph in two parts with a cut set. Now, suppose if this is a cut, right. So, this cut is dividing this graph in two parts, this is the one part and this other is left is the another part, right. So, this cut is passing through branch number 3, branch number 2 and branch number 1, right. This cut is passing through branch number 3, 2 and 1. Now, branch 3 to 1, out of which the branch number 2 is the only branch which is a tree branch, right. This is shown by the solid line. Other two branches are code tree, right. Other two branches are code tree branches. It means ki second one is the twig, that is the branch of the tree, and the 1 and the 3 is nothing but the cords, right. So, this is the one cut set that is shown by C1, that is the, this is the cut set number 1. Now, second is, it could be like this also. Now, the direction says that it is having the same direction as the number of, as the tree branches, right. So, for this the direction is outward. See, this is the direction of your tree. So, the direction of your cut set is outward. It can be shown by this arrow. Direction of your cut set is outward, right. It will follow the direction of your twigs, right. Now, if we take the branch number, 4, 5 and 6, I will just erase it because there is lot of confusion creating here. Right. So, if we take the cut set, that is this one, this is C2 cut set, this is the cut set number C2, it is passing through the branch number, this is first branch, this is passing through the branch number 1, 5 and 6. This is C2 which is passing through 1, 5 and 6, this one, right. So, it is passing through 1, 5 and 6, 1 is the code tree branch, that is the cord, 6 is also the code tree branch, that is the 6, and the 5 number branch is the code tree branch, that is the twig. So, it is containing, this cut set is containing only one tree and the other two are the cords, right. So, it is basically 5 number is the twig and 1 and 6 are the cords, right. So, this is the cut set number 2. Now, the third cut set is also available. If we see this one, node number 2, 3 and 4 is taken, and if this is the cut set. Now, the direction of this will be downward, right. It follows the direction of your twig. So twig, this 5 number branch is having direction in the downward direction. So the direction of this cut set C2 is downward. Now this cut set number 3, that is C3, if we take, it is passing through which branches? 3, 4 and 6. 3, 4 and 6. Now you can easily see that the 4 is the tree branch, that is the twig one. This is twig, this is twig, and 3 and 6. 3 and 6 is the dotted one, it is the branch of the core tree, that is the cords, right. So the total number of cut set, fundamental cut set is nothing but n minus 1, n minus 1, that is equal to 4 minus 1, that is equal to 3. So for this one core tree, there are 3 number of fundamental cut sets, right. Now the next topic is the incident matrix, incidence matrix. Now when a graph is given, right, so from the graph we can tell which branch is going to incident on which node, right, and what are the orientation relative to the nodes other branches having. Or conversely we can say that a graph would be defined if it is if this information, that is which branch are incident at which node with what orientation is given, right. So if we have some information that a branch is going to orient or going to give the direction, that is how they are going to incident on a node, and the relatively other branches are how they are oriented, right. So we can say that if it is a convenient way to say this information is by a incidence matrix, that is the incidence matrix, right. So if we have a information of incidence matrix, so from the incidence matrix we can draw the graph, and from the graph we can make the incidence matrix. Incidence matrix is nothing but a matrix having a row and the columns. It is like we can say that number of row will be the nodes and the number of columns will be the branches, right. So we can see in the next slide also, we will just see some concept how to form an incidence matrix. Now the step for the construction of incidence matrix is, if suppose this is a node and this is a branch, if the orientation that is the arrow sign is going away from this node, then it is taken as +1, and if it is moving inward, towards the node, then it is -1. And if there is no branches which is going to incident on any node, then it will be denoted by 0. And the nodes will represent the matrix row, and the branches will represent the matrix column, right. So by using this concept, we are just going to make the incidence matrix. For example, if this is a graph, then first of all number of nodes is 4, branches is 6. So in the previous slide we have seen that the row is the node and the branches is the column, right. So here we will write the nodes in the rows, and here the branches will be written, right. So node number 4 are there, so 1, 2, 3 and 4, right, and the branches are 6, so 1, 2, 3, 4, 5 and 6 branches. So we can say that this matrix is nothing but 4 cross 6 matrix. 4 is the number of node and 6 is the number of branches, right. Now the entries of this matrix is nothing but the orientation of your branches from the nodes. Suppose we have taken the node number 1. Node number 1 is containing branch number 3, 2, 3, 2 and 1, right, 3, 2 and 1. So branch number 4, 5, 6 is not connected with branch number with the node number 1. So these entries will be 0. So 4, 5, 6 will be 0 for the node number 1. Now 2, 3 and 1 is having 1, but the sign of the 1 is either positive or negative. That will depend on the whether this branch is going to inward or outward to the node, right. Suppose here if we take the branch number 2, it is moving outwards from the node. So it means it is going to be positive, right. See here we have seen a branches which is moving away from the node, it is +1, and if it is going towards the node, it is minus 1, right. So, we will just follow the same concept, it is going away. So, it is 1 for the, sorry, this is branch number 1. So, we will just for branch number 1, it is moving towards the node, right, it is moving towards the node. So, it is minus 1. For the branch number 2, it is going outwards from the node number 1. So, it is 1. For the branch number 3 also, it is going outward from the node, that is also 1. Now, for the node number 2, branches is 2, 4 and 5, it means ki 1 is 0, 3 is also 0 and 6 is also 0. Now, from the node 2, the branch number 2 is going inward, inward means it is minus 1, 4 is also inward, it is minus 1, and the 5 is branch number is 5, which is going outward from the node number 2, that is 1. Similarly, for the third node, 3, 4 and 6, 3, 4, 6 means 1 entry is 2, 0, 2 is also 0 and 5 is also 0, 3, 4 and 6. 3 is going inward to the node, that is negative, 4 is going outward, that will be positive, that is plus 1, and the 6 is also moving outward, that is also positive. Similarly, for the fourth number node, we can see 1, 5 and 6. So, 2, 3 and 4 will be 0, 1 is moving outward, it means it is positive, 5 and 6 are inward, that is going to be negative. So, this is the whole concept of making a incidence matrix. In the next class, we will just see the left topics, which are nothing but cut set matrix, tie set, duality, and the loop and the nodal methods for the analysis. Thank you for this lecture.